All right, good afternoon, everybody. My name's Sean Odell. I'm a developer advocate here at VMware. I've been here 9 years. Forgive me for being here for 9. No, I'm kidding. So a little bit about my background. I joined VMware in 2010. I left and went to a startup in 2015, and I returned to VMware via acquisition in 2016. I was a part of a company called Arkin, which is now known as Network Insight. So vRealize Network Insight or Network Insight from an NSX perspective. So I've been here a while. I've been doing a lot of fun things. In 2017, myself and my peer who was just up here a little while ago, we started a group within VMware focused on the public cloud, focused on applications and the applications in which our infrastructure is consuming. And so my talk today is a little bit of a different twist in some ways. We're going to focus on a little bit about serverless, a little bit about functions in general. I'm going to use AWS Lambda as kind of a basis for the conversation, and then we'll also jump into CloudHealth, and we'll kind of talk about some scenarios that we've seen, as well as we've come up with ourselves. I'll even jump into a GitHub repository that I will share with you, just kind of as an introductory to where you can actually begin to do this yourself. So hopefully that gives a little bit of the background as we jump into it. My title is I'm a developer advocate. It's what I do day in and day out. I focus, in most cases, I focus on the operations side of the public cloud. So I do a lot with CloudHealth, with VMware Secure State, obviously Bitnami, and some of the other solutions that we have within the organization. Our team, we run something called CloudJourney.io. It's content focusing on VMware solutions and in many cases non-VMware solutions. It's really kind of a twist. We have a Twitter presence, and it's really something that I obviously am very passionate about, and we like to really get into what customers are doing. So what I'm going to do today is I'm actually going to do a couple of things. I'm going to focus a little bit on what CloudHealth is, and how we at VMware, obviously we made the acquisition a year ago. Where we are using it as a company, I can discuss that, as well as what we see our customers using it for. And then I will jump into how Lambda can be consumed or utilized along with CloudHealth. And by the way, I'll say it right now, I'm using CloudHealth as kind of the middleman in this situation, but it doesn't have to be CloudHealth. I could actually call AWS APIs and have the same data. But obviously being CloudHealth, we're multi-cloud, so you're not having to manage the API calls. And I'll show you a little bit about the policy as we get into it. And rather than doing a full-blown live demo, I am going to just show you the code and actually walk through it a little bit, and hopefully give you some stepping stones to then begin to actually look at this yourself. I will say there are some prerequisites here. If you've never used Lambda before or AWS before, you are going to have to do some programming, whether it's in Go or Python. You can use something called AWS's Cloud9 to actually help with a little bit of this. And there are 100 of other tools and blogs and everything else out in the market to help you out. So a little bit about serverless. I'm going to ask a question. Anybody using serverless today? Any functions or doing any sort of Lambda from an AWS perspective? Okay, cool. So here's some of the most common use cases. At the end of the day, serverless is still servers. I will say that, by the way. There's still code being run on some box somewhere. But there's a couple of use cases. We as a team actually have a static website, the CloudJourney.io website, which I mentioned, and we use something called AWS Amplify in GitHub to actually push blogs, push changes, whatever it may be. And anytime I commit a change request or a PR, a pull request in Git, AWS Amplify will actually run in the background a series of serverless or Lambda functions and actually process the site and publish the site from a Cloudflare perspective, right? So I personally use the web application utilization or use case, excuse me. And then there's other things, right? Where if I need to make an API call and I need to get some data from one part of an application to another, rather than have an entire server that is only going to make maybe a code call every 2 days or once a month, I can actually take that code and actually put it into a Lambda function and run that in a very quick time span, and I don't have the server that I have to operate and manage and do a bunch of other stuff. When it's only being used to do one thing once a month, there's a lot of use cases with this. There was a scenario on our team where I uploaded my peer's keys, his GitHub keys, his AWS keys to GitHub, and a bot picked up the keys from GitHub and began actually making Lambda calls to our AWS account and started spinning up workloads, right? So there are a lot of use cases, both good and bad. In that case, it's malicious. And then obviously, if you've ever used Amazon's Alexa or even Google's Hello Google, on the back end, those are Lambda functions. And you can actually program against those. And you can actually do a lot of fun things. One of my coworkers, he's standing over there. He actually has a use case where he says, "Hey Alexa," and it will provision a Kubernetes cluster on top of Amazon or VMware, a bunch of different use cases. And so those are just ways to highlight where Lambda or serverless is really beneficial. And then obviously from an automation perspective, simplifying, making policy changes, and I'll use that today. Kind of how this came about from some of the scenarios I'll discuss today is just everyday tasks. Hey, I need to make sure my database is backed up, right? If I'm using MySQL or if I'm using an RDS or a Cosmos DB inside of Azure and I am making sure that it's backed up, I can run a Lambda function that says, okay, I'm going to go out to my MySQL instance sitting out on Amazon or even on premises for that for that matter, and I'm going to run a MySQL query and dump the database and make sure it's backed up, right? Whether it's to a third party, to a backend system, whatever it may be. And so that's how we kind of came about this, looking for a particular date in a field in one of the tags from AWS. So there's a lot of use cases. So talk a little bit about CloudHealth. Obviously, you've been here today. You've probably heard in this morning's keynote about CloudHealth. We did make an acquisition of CloudHealth about a year ago now. And CloudHealth is primarily focused, when we made the acquisition, obviously that's changed since, but was primarily focused on the public cloud and how consumers were spending and utilizing and really just gaining general visibility of their workloads in the public cloud. In the native public cloud. And what I mean by native public cloud is Amazon, Azure, AWS, or Google. I'm not discussing VMC in that sense. So since we made the acquisition, CloudHealth now obviously integrates fully with the VMware data center and the VMware hybrid cloud, right? This was one of the announcements this morning. And so what we've done is we use CloudHealth as kind of the inventory of record, or the architecture underneath which I'm gathering all of my tags from AWS, I'm gathering all my tags and details from Azure, and I'm using that information to make changes or to run a policy against a particular field, and I'll show you that here in a second. So the goal of CloudHealth is really about agility and understanding what you have in your environment, and more importantly, using that in an actionable fashion, right? So CloudHealth natively supports taking AWS workloads that are over-provisioned and doing some reclamation and right-sizing those properly. Or if I have a bunch of EBS storage volumes that are not used but are costing me money, we will quickly identify those and we can shut those down or delete those if you chose to. Or you can take a workload that maybe is doing some work and it's idle for most of the time, or if it's a development environment, maybe you want to shut it down at 5 p.m. on a Friday so that you're not using resources Saturday and Sunday. Within CloudHealth, in the platform itself, those are supported automatically. I don't even need to use an AWS Lambda function to make that happen. It's already supported. But what if it's a use case that's not out of the box, there's not an easy API call, or maybe it's just something different that I want to use? And so we've seen a lot of our customers, we as VMware use this as well, where we use CloudHealth kind of as that middleman in this scenario to help us then save money, be more secure, et cetera. And so this is just kind of a high-level overview of what we're doing in CloudHealth. So in the serverless world, there are some cost benefits, right? I've obviously talked about CloudHealth and some cost savings. And really this is where, look, I'm not here to say there's a right scenario for every workload, and this really gets into what is best for the organization, right? Your choice. But at the end of the day, it can definitely be cheaper to, if I use my example about our website, if I was to run infrastructure that's doing the provisioning day in and day out, I would be using those resources and paying for them. But instead, anytime there's new code push, I spin up the environment, make a few calls, and then spin the environment back down. Right? So I'm not having to maintain the infrastructure that's doing builds maybe 4, 5, 6, 7 times a month. Right, in the case of that scenario. So really the goal is about provisioning or less provisioning in that fashion. The beauty of serverless functions is also it scales with usage. Because I'm literally just running code, I can set some parameters rather easily if I'm the end of the month, end of the quarter, right? There's just a lot of ways to look at it. And more importantly, I never pay for idle, right? Inside of native AWS, the second you spin up a workload, whether it is powered on or not, you are paying for it, right? And so in this case, it's just another example of doing so. And I will be the first one to say not every application, and there is not a situation where every use case works inside of serverless. That's just not true. And it does vary by workload, it varies by application. Some make sense, some don't make sense. And so we leave it up to you. We believe that it is absolutely up to you to drive the use case, right? It could be obviously continuing down the VMware virtual machine path. It could be moving the application to Kubernetes. It could be a serverless function to go along with it. There is, and I am a firm believer, don't try to take a workload that should be based on Kubernetes and put it into serverless. Or if it needs to be a monolith traditional VM, don't try to push it over to serverless. It's not going to matter. It's not going to benefit you in any way. It's going to be a lot of trouble. And the cool thing is availability and obviously fault tolerance falls into that. So this is the way kind of Amazon describes how Lambda works. So there's a change in state. I'm going to request an endpoint to give me some information, a change in state in a lot of ways. I'm using this in the scenario I will demonstrate here today. I'm using CloudHealth as the event source for this particular example. But it could be something else. It could be a database. It could be a tag. I mean, there's so many different use cases that go along with it. From there, I will take that information and I will push it into a Lambda function. And then ultimately, I am going to make a change somewhere or do something as an output. So I have an input, obviously being the event source. I have the function, which is the code. And then ultimately, I have the execution of that service and what it is doing. So let's jump out of here. I am going to show you CloudHealth real quick to help articulate this somewhat. Hold on. Where's my mouse? I have apparently lost my mouse. There we go. Now it's back. All right. So just to help drive this a little bit further, so I've got CloudHealth here, and while we think of CloudHealth, obviously we've talked about it today in the keynote. We're focused on cost visibility and analysis. One of the keys behind CloudHealth is we are gathering all of the information from those workloads in AWS, Azure, and Google. So if I look at my assets here inside of my environment, let me look at AWS. I've obviously got all of the data types. If I check RDS, I have an RDS instance that's running in my environment, and I can view all of the information, right? So here's everything about this particular workload. The DB name is prospect. This is associated with one of our applications, right? This comes natively from AWS. We're just making an API call, gathering the information. It's very simple, and it's honestly really easy to use. But with this information, I can then take actions, okay? And I think this is just kind of a simple use case. So if I look at my tags, I see that this workload, in this case, this particular object does not have a tag. And that's okay. For demonstration purposes, I didn't really need it in this example. But this is a real workload, right? It's out there, it's functioning. I get to see its list price, right? I have all of this data. I could take action on any of this information. So what we've done is, provide you that mechanism. In this case, we're using CloudHealth as that event source. One of the things that we allow for is we have governance policies. And those governance policies are a variety of different things. They could be AWS best practices, could be your own set of policies in situations or solutions. But more importantly, we will allow you to take action on said policy. So I wanted to show you what's out of the box. So this is some of the things from an AWS perspective. I could stop and start, or I could modify an EC2 instance. These are the things that we have made available today. Right? I can delete a snapshot. The one thing you don't see on here is the ability to run a Lambda function. I'll show you where that actually comes about. By the way, this supports, we also do things in AWS, Azure, Google, so it's not just AWS. But the thing is, I can create a policy. And so in my example, I'm actually going to use one of my coworkers who's standing in the back over there. He's built this. We're looking for EBS volumes, and we're going to that are untagged, and we're going to email. You have the rules engine within CloudHealth is actually very easy to use. The key is you can create a policy based upon any of those attributes that I showed you earlier. Right? It could be a cost, it could be a tag, it could be the type of RDS instance. A fun example, that's out of the box is if Tim on my team spins up a M4 XL, $10,000 a month workload, I could use the policy to actually stop and delete that instance. Right? That's one of the options. So it's pretty simple to use. But when you look at the rules, and I could pick a variety of conditions. But here are the available actions. So we've got some out-of-the-box actions, but notice this function here, run Lambda. Right, pretty simple stuff. And we're going to continue to expand on this. I personally like this more because it gives me some freedom. I can do things outside of the AWS CLI or AWS APIs if I wanted to by actually running some code against it. So for the sake of time, and rather than breaking the world, I'm going to show you a little bit about what we've built to help with this. So the event source obviously being CloudHealth, and we've done our team's done a really good job. We've actually articulated this pretty well. We have a README on here. But if you look, I've got a list of functions. In these cases, I've got 3 examples. In each of the cases, they're written in Python as well as in Go. And so I'll jump into those in a second. But really the goal here is pretty simple. Hey, I need to install SAM so I can make a connection to the AWS CLI. And obviously I have to have Docker to do this as well. But currently we're stopping RDS instances, snapshotting EC2 instances outside of the already capabilities, modifying an EBS volume, right? Just very simple things. And we come up with fun ideas all the time as well. We just haven't put them in here yet. So in this example, let me jump into the Python code here for an EBS modify. So this is the Python example. Yes, we do tell you, hey, here's the application, the Python code. We've got the sample event that comes from CloudHealth, right? I showed you in the GUI that it says run a Lambda function. That run Lambda function is actually what's outputted from the API. And so that's what we're going to consume. We give you an example to help out here. And then a couple other bits, right? We got the README, the makefile, the requirements text for Python, which makes your life much easier. And then ultimately the SAM deployment file from an AWS Lambda perspective. So let me actually jump into VS Code real quick, and I'll show you a little bit of the code that we have in 2 examples. So here's the Python code. So here's the application itself. We are in. Let me expand this a little bit. That should be a little bit better, if not too big. But we're going to actually do a couple things. We're going to do a couple of imports to understand the native libraries from an AWS perspective. And then we are actually going to run a Boto3 command against a particular region. And we are setting a couple of variables in here to actually get very specific on what you're wanting to do. And then we are a very simple print to set a few environment variables. And then ultimately, we are going to schedule this execution. So let me show you the event JSON. This is actually the payload that CloudHealth will return. So in an example of an EC2 instance, right, I need to know, I don't know, whatever it is, do they have tags, or do they, is it a particular instance type? Could be. Well, the payload that we're actually going to return from CloudHealth's API is the 2 ARNs that are associated in this example with those EC2 workloads, right? And so I'm actually using the JSON return or the payload, and I'm calling that from within the application, which is pretty simple, easy to use. Let me show you what this looks like in Go. And you're probably like, well, I need to test this myself. Yeah, I'm with you. So let's jump into Go. This is a little bit better from a programming perspective, at least for me. I hate Python, but that's what they wrote it in. So in this case, here's my quick import. Notice this. Here's my function in my handler in this case. I'm going to get the ARNs from the CloudHealth message. The payload from CloudHealth shows me those 2 ARNs. I'm going to request those, right? And then Leon, who wrote this one particularly, he gave some really good instructions. He's going to create a new session without AWS credentials. He is going to then, this is basically a Lambda function that has the privileges to run the associated code. And he's going to, within that particular function, he's going to call EC2. He is going to take those ARNs from the payload from CloudHealth and actually plug them in, and then run whatever that particular code may be. In this case, it's because we're modifying the EBS volume. But if you were making starting a snapshot, running a database backup, like there's so many different ways to do this. But the goal is ultimately to run those particular EBS stages, get the volume ID, modify, and here's the modification, right? Very simple. By the way, Leon always creates a dry run just in case it fails, and then shows you the volume ID he's going to use. He's going to make the size changes, and then ultimately run and execute the particular modification, which he has here. And then at the end, obviously, we want to return the status. Did it pass? Did it fail? Did something break? That never happens. It actually always does. And then obviously, that's all wrapped up. In this case, is the Go. This is the Go example. We have a couple more examples in this particular repo. I'll make sure it's available to you, or it is public. Excuse me. It's already out there. And really, this is just kind of to get you started, to get you thinking about each of these. And at the end of the day, these are just simple examples, right? This is not something that is some unique. We've seen this all, in many different fashions. Obviously, we chose a few examples, but you're going to come up with your own ideas, and it makes sense for you. In the case of, it's probably better to run these as functions rather than, spin up an entire infrastructure or an EC2 instance or a VM, whatever it may be, and I can just run it in a very simple form. So let me jump back into the into GitHub. So our repo, wow, I don't know if that's me or what. But here's our repo here. You can actually see a couple of the examples. If you go out to cloudjourney.io or if you follow us on Twitter, I'll make sure and put the link available to you. We definitely make this very simple, and we're continuing to add different objects. But these are the examples that you have out there and available to you today. So I'm going to, I think I have one more slide. Yeah, here's the repo. And then I'm going to highlight this, and then I'll take any questions. So one more, hold on. There we go. Perfect, there it is. Any comments or questions about what I have shown you today? I'm not a sales guy in any form, but I can say it's based upon your cloud spend. Yeah. No. I personally have, or our team, I should say, we have 9 separate accounts across all of the public clouds, and that's kind of a norm across VMware. We have many thousand, if you want to say that. So it just varies by organization. But yeah, it's by cloud spend. Yeah. Any other questions? Okay. I appreciate the opportunity. Thanks for coming out. Enjoy VMworld. Enjoy Barcelona. And I'll stick around if you have any other questions. And thank you for being VMware customers. Thanks for being here. And I really appreciate all of you. Thank you.